Okay, this will be the last video for chapter 8. In this chapter, we're going to go ahead and look at, in this video, we're going to go ahead and look at the second level method called the LCR method. So for this one, instead of a rules of thumb, the LCR method is based on extensive computer-based analyses of various passive solar features in a variety of cities. So this LCR method is philosophically similar to the F-chart approach for active solar features discussed in chapter 7. The LCR method is specific to a given structure in that the NLC and the projected solar area, A sub P, are required. From these two quantities, the LCR can be determined from the given definition earlier. Once that LCR is known, the solar savings fraction can be found for a given city by matching the LCR with specific passive solar features. So there are 5 different passive solar configurations covered by this method. And those 5 are the direct gain, the vented trum wall, the unvented trum wall, the water wall, and the sun space. So let's go ahead and turn to Appendix B in the back of your book. So that would be located on page 415. That starts Appendix B. If you skip ahead to the next page, 416, you can see each of those 5 different passive solar configurations listed, and then they have different features that gives them a specific designation. So for example, each of them have varying number of glazings, thermal storage capacity, wall thickness. Some of them might have some nighttime insulation or not. And what happens is that those specifics, those variations of those features gives it a specific designation. For example, if you were to go to water wall, WW, WWA1 is a designation for a water wall that has a thermal storage capacity of 15.6 BTU per foot squared Fahrenheit and a wall thickness of 3 inches with 2 glazings, that the wall surface is normal, and that it has no nighttime insulation. So the idea is that you would find out your specific designation based on the solar features. Following that, you would actually go further in, and starting on page 419, you'll see, for example, on 419, it gives you different LCR values for Santa Maria, California. And then as you advance to following pages, it has the same data for different cities. So the idea is that you take your designation, your specific passive solar designation, you match it to the LCR that you calculate, and then you go to the top of the chart where it gives you the solar savings fraction. So as you can see on the chart on page 419, the topmost values is SSF, solar savings fractions, starting from a value of 0.1 up to 0.9. I hope that's clear. In order to make sure that it's clear, we're going to go ahead and do an example problem. So in this example problem, it reads that a 2,000 square foot home with passive solar features is located in Nashville, Tennessee. A heating load analysis determines that the NLC is 12,000 BTU per Fahrenheit heating degree day. So the home has 150 square feet of direct gain solar glazing, and characteristics of the direct gain features include double glazing, nighttime insulation, 30 BTU per foot squared Fahrenheit thermal storage. And it's asking you to determine the solar savings fraction and the auxiliary heating needed. So again, as mentioned earlier, the first step is to go ahead and compute the LCR, which is the net load coefficient divided by the projected area of self-bathing glazing. So we get 12,000 BTU per Fahrenheit heating degree day divided by 150 square feet of direct gain solar glazing. That equals 80 BTU per Fahrenheit heating degree day foot squared. So that's the first step. The second step is, let's go ahead and get our passive solar configuration. So this is it's already telling us that this particular system is a direct gain system. So the direct gain system would start on page appendix page 416, if you go down to the middle of the page, it says B. So table B1B. So this would be again be in table B1B. You should see that it is a direct gain system. So it's telling us that it includes double glazing, nighttime insulation, and 30 BTU per square foot Fahrenheit. So if you were to go ahead and try to compare those, you'll see that this is designation A3. This is DGA3. With that said, on state number 3, we're going to go to page, let me see here, page 423. You'll see the LCR, LCR values for Nashville, Tennessee. And with that said, we would go ahead and go down to designation DG. So that would not be on page 423. We'd have to go to page 424 and go down the line to DGA3. So again, for DGA3 and an LCR of 80, we should find that the solar savings fraction, you should be able to interpolate for it pretty easily. So in this case, the solar savings fraction would be about 0.2. Now, what's interesting about this table that we just looked at, if you go to the beginning of it, back to, again, this is, you see, table B4. If you go back to it, excuse me, it also gives us the number of heating degree days. So in this case, the heating degree days, sorry, that should be HDD, not HH. So the heating degree days in the upper right-hand side of the chart, it tells us is 3,696 degree days. So with that, we can go ahead and we can calculate the auxiliary heat needed. So that would be 1 minus the solar savings fraction multiplied by the net load coefficient multiplied by the number of heating degree days. So in this case, we would need 35.6 times 10 to the 6 BTU in total auxiliary heating needed. So anyway, I hope that's helpful. This example problem concludes our last video for chapter 8.